rounding, sums, and differences. What's the word estimated mean? Guessing. I like that. But we got to make an educated guess. We just don't want to just go and throw a dart and wherever it lands, oh, that's what it is. All right? So we're going to use what? Rounding. Rounding when we're estimating. We want to make a good guess. We want to make a good guess. Now, we've done a little bit of this rounding of fractions way many weeks ago. And I taught you one way to do it, and today I'm going to teach us a little bit different way. Maybe it'll be easier this time. Okay? So, we're going to look at something like this. That's what it looks like. And we want to estimate this. We don't want the exact answer, we just want to get close. We just want to get close.
Model.
What's the next word? Come on, y'all.
Model.
Model. I like that. Draw a model. We're just going to draw a model. Bless you. We're going to draw a model. And we're going to use the bar model, not the pizza model. Okay, is that all right?
Yes, sir.
Pizzas are a little bit harder to understand. So we're going to draw a bar model. Now, how many do I have right here?
4.
4 what?
1/3.
4 holes. 4 whole things. So I need 4 boxes. And they're whole ones. Now they need to be close to the same size, but you get the idea, right? They're close, aren't they? 4 holes. But I have an extra one, don't I? But it's not all the way colored. How much of the extra one is colored? 1/3 of it. Which means I need to bust that stick into 3 pieces, right? And color how many of them? 1. Draw a model. Okay. And then you got to ask yourself, will the extra... No, not will. Sorry. Is the extra... I'm sorry. Just scratch it out. Don't erase. Just scratch it out. You got to learn how to scratch out on doing notes. You waste your eraser. Is the extra more than half or less than half? If more than half, round where?
Down.
More than half,
Up.
round up. There you go. If less than half, round where?
Down.
Down. Bless you. Man, someone's got the bad nose over there. If you need a plug, I'll plug you up. I just got to walk around with you all day. That'd be bad. My finger's up your nose.
Ew.
That's nasty, ain't it? All right. So, looking at our first 4 1/3, is our extra piece right here more than half or less than half?
Less.
Less than half? So, I'm not going to count him. We're just going to have 4. 4 holes. I did round down. I had 4 1/3, 4 and more, but I took off the more and say I've just got 4. So that's rounding down, isn't it, Sam? All right. All right. Let's do the second model. What do we have?
6 holes.
6 holes. So 1. You notice my pictures aren't perfect, are they?
No, sir.
But they're close. Sometimes we get too concerned about having pretty art and forget about we're doing a math problem, okay? Don't worry about pretty art, just get close. Now, is there extras on the 6?
Yes.
6 and how much?
8.
5/8. What does my last stick have to be busted into?
8.
8s, and I'm going to color 5 of them. So, let's see, half of the halves is 4, and half of the fourths is
8.
8s. And I'm going to color
5.
2, 3, 4, 5. One, 2, 3, 4, 5 of them. Now, looking at the extras, is our extra here more than half or less than half? More than half. So I'm going to go ahead and color the whole thing in. I'm not Xing it because I need more than means round up. Less than is down. So we're more than, so I'm going to round up. And my 6 has now turned into 7. Do the or now. This is a 1, which equals
11.
11. Now, several weeks ago, I tried to teach you we need to graduate to looking at the fraction 1/3, looking at the fraction 5/8, and we've got to graduate our thinking process to where we don't have to draw a model to do it. We've got to be able to look at 1/3 and see in our brain that 1/3 is less than half. Because what is halfway to 3? 1.5. And 1 is less than 1.5. So 1/3 is less than a half, round down. Take off the third, in other words. Does everybody see? We got to graduate to that sometime before next year. We don't have time to draw models forever and ever. Okay, Travis? We also, Travis, have to notice 5/8, and in our brain, graduate to the thought, what's halfway to 8? 4. The 5 is bigger than 4, so 5/8 is bigger than a half, or more than a half, so we're going to round up. The 6 turns into a 7. Now, at some point, we've got to graduate our thinking to that point. But if we're not there yet, it's okay. We can draw us a model and find whether it's bigger or littler to get half. Okay? Everybody with me? You with me on that? Some of you may already can graduate to that thinking, and that's awesome if you can. But if you can't, I was one of those that was slow getting this stuff, all right? I had to draw models. I didn't show us this way back second week of school, third week of school. All right? I think this will be easier for some of us who haven't graduated our thinking yet, and that's okay. I'm not saying bad things about you if you can't graduate there yet, but you're going to have to someday. All righty? You're going to have to someday. You're almost a nice guy. Thank you. All right. So, let's do another example.
Do we have any more notes?
Got a whole.
No, like on this page.
I've got a whole nother thing right here. Man. 3 plus 8 and 7/20. I want to estimate this. All right, let's estimate 3.
3.
Good job. There's no estimate. It doesn't have a fraction with it. So it's going to freak out on that, right?
Yes, sir.
All right. Now, 8 and 7/20. What do you think, Travis?
I think it's going to round down to 8 because half is 10.
Halfway to 20 is
10.
10,
So, and that's below,
and 7 is
below 10.
below 10, so we're going to round down, so 8 stays 8. Now, could we, if we're not there yet, done this?
Yes, sir.
Yes, sir.
4,
The 7
5,
should be kind of
6, 7, 8 of them, okay? The problem is now I got a fraction with what in it? 20.
Just draw it really big.
All right. There's halfway, halfway of halfway, right? And halfway of halfway, right? How many have I got up there now?
10.
1, 2,
Eight.
3, 4, 5, 6, 7, 8.
16.
16,
Just have them square.
17, 18, 19, 20. 7 of them. 1, 2, 3, 4, 5, 6, 7. Halfway?
No.
No. Stays 8.
That would take.
Equals
11.
11 also. Oh, same problem, sorry. What do you think about estimating?
Easy.
Easy squeezy, greasy, whatever? Easy squeezy, greasy hair? All right. So estimating should be easy. We're guessing, but we're making an educated guess. All right? Now let's take some fractions and let's go ahead and get them added. This should be a review from 5th grade. We're over here now, Chicky duck friend.
No.
You learned this last year, so we're going to reinforce it right now. Adding and subtracting fractions with like denominators. For instance, I'm going to put an example right here. Let's go. Four 11s plus 5 11s. That's what they look like. That's what they look like. What does that mean?
Very important.
This is the whole key, the very important thing, the whole key to adding fractions. When? Oh. I'm abbreviating so we can go faster. Is that okay?
Yeah.
When and fractions. What does that say?
When adding and
And
subtracting.
fractions. All right, when adding and subtracting fractions, you must have the same denoms. I'm just going ahead and making this point right now, because sooner or later we're going to have to add fractions that don't have the same denominator. But I'm making the point right now. We must have the same denominators, which is the same bottoms. Or you can't add them. You got to change them to add them. So they cannot be added if they do not have the same bottoms. Today, friends and loved ones, after we're done with estimating stuff, when you go to the problems that say add or subtract the fractions, they're going to have the same bottoms today. But next week, I'm probably going to get you with the ones that don't have the same bottoms. One might have a fat bottom, one might have a skinny bottom. Alrighty? Alright, so they must have the same bottom. If they, okay, like denoms, oops. Add or subtract. Now, this step right here confuses students because I write add or subtract, and so they go, well, I just wanted to add this one. Well, Depends on what the problem is. Can you believe I actually had a student say that to me? Well, it says add or subtract like it was my choice. No, it's not your choice what to do. If the problem's an add problem, then add. If it's a subtract problem, subtract. I actually had a student tell me that once. I thought I was going to knock his face off. Add or subtract means whatever the problem is, do that, please. I have to say that from now on. The kid's out of school now. I hope he's successful. Take care of him, somebody. Add or subtract the numers. Now that doesn't say numbers, does it?
No.
That's our abbreviation for
Numerators.
numerators, the tops. So, on our example over here, we check the denominators are the same. Remember, it says it's got to have like denominators. They're alike. So, we add or subtract the numerators. This is an add problem, so add the tops.
11.
9. Oh boy, it's hard stuff. Step 2. Tell them
Keep
keep
the
what,
denominator.
Higgs? Keep the, what, Higgs?
Denom.
Keep the denoms. Which is the,
Bottom.
you keep the bottom. So, the 11 stays 11. Tell me what's the most common mistake students make with this?
They add the
They
denominators.
add the bottoms too. No, 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 no. Never add the bottoms when you're adding and subtracting. Never add and subtract the bottoms. The bottoms stay the same. Okay. There is a step 3. Ooh. But it looks like we're finished, doesn't it?
Round it.
No, round it.
Simple.
Buddha. Simplify the fract if possible. We must look at it and will it simplify. Now remember, what are we talking about on simplify?
Smaller.
Divide by. Divide by. That's our divide by, simplify. Watch out for
Improper actions.
You better watch out for impropers. They're going to sneak up and bite you too. And those simplify is what?
You have to like
Divide.
bottom into top.
And what do we do with the leftovers? Put them up top and keep the same. Ooh, see all that stuff we learned 4 weeks ago is coming back to haunt us?
Yeah.
Yes, it is, isn't it? Getting close to Halloween and stuff's coming back to haunt us. Or like a bad bowl of beans from Taco Bell, it'll come back to haunt you after a while. You better watch out for impropers. Okay?
Was that cowboy?
Okay? Okay? That's cowboy in the house, but we don't make a decimal answer though. We make a fractional answer. Okay? All right, let's go with 3 sevenths plus 5 sevenths.
You just add the top.
Are the denominators the same?
Yes.
Yes, denominators are the same. Add the tops. 3 plus 5. 8. All right. What next?
7 for
Same denom. 7, 7, 7. Ooh, bang, shang-a-lang. Improper. I can't circle that. It's top heavy. Improper. How many 7s will divide out of 8?
1.
Big 1. How many leftovers will you have? 1 leftover. Where does the leftover go?
On top.
On top. And what is our bottom? Same 7. There is simplifying improper fractions. See, we've already done this year, right? So it comes back. We can't just learn it 4 weeks ago and then, oh, I'm going to forget about it now. Oh, it will come back and, oh, get you in the wrong. Bite you on the buttocks. All right, let's do a few examples like this right here. You move up. Get up in there real good and tight. So your ugly face don't get in this picture here. All right.
You got my one.
We're going to estimate these. So Lexi, read that first one about Carson.
Carson worked 4 3/4 hours. Gabe worked 7.5 hours. Gabe worked how much longer?
Now, what's the question here?
How much?
How much longer? Does it say how much did they work together? No, it says how much longer is one than the other, which implies what mathematics? Subtraction. So here's a minus problem. So which is the bigger number? 7 and a half minus the other person, 4 and 3/4. Now we're estimating. Let's make it easy. 7 and the extra is a half. What do we do with halves?
We add up.
We round up. Go ahead and round up if it's halfway or bigger. Okay? So now that's a 8 minus. Now 4 and 3/4. What about 3/4?
A half is 2/4, so.
Half is 2/4 and 3 is bigger than 2/4. So we're going to round 4 to
5.
5. So how much longer?
3 hours.
3 hours.
And
Now, how hard is that estimating? Y'all?
Easy.
Not. Very good. Let's go back to Sarah back here on the back side. Brownie?
Sarah had 35 feet of wallpaper border. She used 26 5/8 feet. How much was left?
What's the question? How much is left over? Are they putting them together? No. Because if we're looking for how much left over, that says we're going to subtract them. 35 minus 26 and 5/8. 35 is already estimated. What about 26 and 5/8? 5/8 is
More than
over
4.
4/8, which is half, right? You with me, Lex? 5/8 then goes to, all right, and what does that turn out to? 27. 35 minus 27.
13.
35 minus 27. 35 minus 27. 35 minus 27. 35 minus 27.
8. Because 3 plus 27 is 30 plus 5 is 35. That's 8.
How many?
8.
Thank you. There was a whole lot of different answers coming out there, so I had to get everybody on the same page. I know, I did too. Man. Let's go to Jana. Melissa, Jana right there.
Jenna bought 1 1/2 pounds turkey, 2 1/4 pounds of ham, and 3 3/4 pounds of beef. How much meat did she buy?
What's the question? How much did she buy? That sounds like
Add.
all together total, right? So 1 1/2 plus 2 1/4 plus 3 3/4. Well, what about 1 1/2? 2, because halfway or more, we round up. You with me, Lex, girlfriend? Oh, good job. All right, Carly Joe. What about 2 1/4? Carly Joe, what? Stays 2, doesn't it? Because 1/4 is littler than half, because half would be 2/4, right? Good. All right. And Janel, 3 3/4. We're going to take that to 4 because 3/4 is bigger than 2/4, which is half. Very good. I see this class has graduated to the thinking without drawing a model, right? Good job, y'all. 224. 8 pounds of beef or meat. Okay? All right? Now, slide your chair, girlfriend. We're coming back here in the back. Don't make nobody sick.
Okay.
There you go. All right. Now, what's the instructions here, Ty Rosk?
Add or subtract, just simplest form.
Add or subtract, and then we want it in simplest form. 3/5 plus 1/5. Nope, you're saying it wrong.
4/5.
Nope, you're saying it wrong. You say, look for the denominators.
The denominators are the same.
Right. You tell me first, the denominator's same. That tells me you're looking at them, because I promise you next week, I'm going to kick you hard in the Rumpelstiltskin. Because I'm going to throw ones up there that don't have the same bottom. And then I'm going to mix some in that do have the same bottom. And you got to be able to tell the difference between the two. So tell me, you seeing that they are the same. Now, what do we do then? Add the numerator. Whoop. Add the denominators.
No.
Oh, no. Good job. That's right. Denominators stay the same. Simplify. Nope. Can't do it. Good job. 4/7 plus 5/7.
Denominators are the same.
Okay, denominators same.
4 plus 5 is 9.
9 sevens. Uh-oh. Impropers. How many sevens make 9? 1. Do we have leftovers?
Yes.
How many?
2.
2 leftovers on top of...
7.
You with me, Lexi girl? You're yawning over there. Stay with me, girl. Concentrate. 5/6 minus 3/6.
Denominators are the same.
Denominator same.
5 plus 3 equals 8.
5 plus 3. Ooh.
2.
Oh.
Another one of the most common mistakes, you get in the mode of I'm adding, and all of a sudden I throw a minus in there, and you keep adding. No. It's a minus
2.
2, 6. Oh, this is one of those divide by simplifies. By 2, and we get
1/3.
1/3.
1/3.
1/3. 9 11s minus 4 11s.
And look, the denominators are the
Denominators
same.
same.
9.
9 minus 4.
5.
11 minus 11.
No.
No. Don't do that. Just keep the 11. Right?
Yes.
Okay. So I couldn't fool you today, could I? All right. Kill it, girl.